Hi coders, CS Time channel here, and this video discuss about how to delete a node at the end of a circular singly linked list. When we wish to delete a node from a circular singly linked list, there are two possible situations. The first situation is when your list is empty. The second situation is when your list is not empty. When your list is empty and you wish to delete a node from a circular singly linked list and you have a pointer in your circular singly linked list, here I call it as head, then your pointer will point to null like this. And if you wish to delete a node from this situation, then to avoid error, your program should throw an exception. Another situation when you wish to delete a node from a circular singly linked list is your list is not empty. When your list is not empty, the first situation maybe look like this. Your list only consists of one node. And if you wish to delete the only node you have here, then you just need to instruct the head to point to null. By giving this instruction, our circular singly linked list will look like this. The head point to null and the node was pointed by head will be unreferenced like this. Another situation, if you wish to delete a node from a circular singly linked list and your list is not empty, your circular singly linked list maybe has many nodes like this. And if you wish to delete the last node from the circular singly linked list, then we need a help from another pointer. Here I use temp that I instructed to point to head. By giving this instruction, our visualization will look like this. The next job to do is to instruct the temp pointer to point to the node here. The instruction will be temp equal to temp.next. By giving this instruction, the visualization will look like this. We will keep on telling temp to move to the next node until we find the last node. To do that, we need the help of another pointer. Here I use temp2. I instruct temp2 to point to temp. By giving this instruction, the visualization will look like this. Now I will instruct temp to keep on moving to the next node. As temp move to the next node like this, temp2 will move to the node previously pointed by the temp like this. This instruction will keep be repeated until the next node pointed by temp equal to head. To do that, we need to wrap this instruction under looping. I use while here with the condition temp.next not equal to head. Once the temp.next equal to head, then we will quit the looping. Once we quit the looping, temp.next equal to head, we know that temp is in the last node. In that condition, we are ready to delete the temp. Once we quit the looping, then we will instruct the temp2 pointer to point to this. The instruction will be temp2.next equal to temp.next. By giving this instruction, the visualization will look like this. As you can see in this picture, the temp pointer still point to the head. We need to break this chain. To do that, we need to instruct the next pointer belong to the temp.next to point to null. By giving this instruction, now the temp will point to null like this. Let's see the Java implementation. I'm still using the same program I used in the previous video. In the previous video, the program can do the creation of the circular singly linked list, the traversing of circular singly linked list, the insertion, which is insert first or insert in the beginning, and then insert last, and the program can also do the deletion, which is delete first or delete the first node of a circular singly linked list. Before we start writing the method on how to delete the last node of a circular singly linked list, okay, let's run this program first. So here is the result of the program. I tested with the insert last for X and then insert last for Z. Now I will run the delete first. So after running, the result is X has been deleted here. Now let's write the method on how to delete the last node of a circular singly linked list. I declare it as public circular sing list. I name it as delete last. As an explanation just now that the first situation maybe your sing list is empty, so I will just call the empty method. If the length is 0, it means it's empty. So to avoid error, then we will throw an exception here. Another condition is our circular single linked list is not empty. The first situation when our single list is not empty is maybe it only has one node. I will need another pointer. I use temp here. Circular single list temp equal to head. We know that it only has one node when the head point to itself. So head equal to head dot next. When it's point to itself, we know that it only has one node. And if you wish to delete that node, then you can simply tell the head to point to null. By doing like this, you delete the only node it has. Another situation when your list is not empty is it has many nodes. So else here, now we need the help of another pointer. I use temp2 here, circular single list. I use temp2 and I assign it to point to temp, and then I will keep on telling temp to keep moving to the next node until temp.next not equal to head. So I will use while here, and then I will do the checking while temp.next not equal to head, then I want my temp move to the next node. Temp equal to temp dot next. As the temp move to the next node, we want the temp2 to be in the previous node pointed by temp. So temp2 equal to temp. When this condition is wrong, meaning temp dot next equal to head, then it will quit the looping. Once we quit the looping, we will instruct temp2 dot next to point to temp dot next, because temp is pointing to the node that we wish to delete or the last node. Now we want to break the change of the temp because we want to delete the temp. So temp.next equal to now. Once we delete it, we can reduce the size of the node. We can return the temp. Let's say it one more time. As in our explanation, then the first situation when you wish to delete a node from a circular single linked list, the node may be empty. So to avoid error when you attempt to delete it, then we throw an exception. Another situation is when our list is not empty. The possibility when our list is not empty is it only has one node. Another possibility, we have many nodes. When we have only one node and we wish to delete it, we know that it only has one node when the head point to itself, and we wish to delete it, then simply we can instruct the head to point to null. By doing like this, we break the chains of the node pointed by the head. Another situation when it has many nodes. When it has many nodes, it means we need to traverse all the nodes until we find the last node. We know that it's the last node when the node dot next equal to head. When it's point to the first node, it means that node is the last node. Then to do that, we need the help of another pointer, which is temp2. We tell the temp2 to point to the temp. Temp will point the node that we wish to delete. So we will traverse the circular single linked list using temp pointer. We instruct the temp to keep on pointing to the next until the next node is head. As temp traverses to the next node, temp2 will also traverse to the next node, but always pointed the previous node pointed by the temp. Once this one is not fulfilled, which means the temp.next equal to head, we know that we find the last node. It means the temp is in the last node. So now we want to break the change of temp1. Before we break the change of temp1, we need to link first the temp2.next to link to the temp.next, which is linked to the head. After that, it saves to break the change of the temp, and then we reduce the size and then we return the temp. Let's try it now. So delete last here. Maybe I will just comment this one and I run it. So here we call the insert last, we insert X, and then we insert Z. So our node consists of X and Z. When we call delete last, it should delete Z. So left in the circular single linked list only X. If we run both of it, say we open all the previous program like that, we run it. So in our program, we have BAXZ, and then we call the delete last, it left BAX. If you learned something from this video, please subscribe and like for more videos. Thanks for watching.